Communities webinar. Today's webinar is titled Accessible Pedestrian Signals, and we will be speaking with Daniel Carter, Senior Research Associate with the UNC Highway Safety Research Center, and Janet Barlow, President of Accessible Designs for the Blind. My name is James Gallagher, and I am the PBIC Communications Manager. I will be facilitating today's webinar. For more information on future webinars or to view the archives from this webinar series and others, please visit pedbikeinfo.org/webinars. You can also stay abreast of PBIC webinars by following us on Facebook at facebook.com/pedbike. In addition to these webinars, PBIC offers 4 different in-person training courses to provide technical assistance to professionals and community members in developing pedestrian safety action plans and in improving conditions for walking. These courses can be found at pedbikeinfo.org/gettraining.
All right, advance this a slide or so. This is titled Designing and Retrofitting Intersections for Accessible Pedestrian Signals. Daniel and I have been working for a number of years now on the NCHRP 362 project together. This project basically began with some research on accessible pedestrian signals, what features worked well for individuals who are blind or visually impaired, and usability for people who were blind. We did that research in 3 different cities. After that research was completed and analyzed, worked with the Access Board and the National Committee on Uniform Traffic Control Devices on some recommendations for the guidelines for accessible pedestrian signals. And after that, that has resulted in some guidelines being published, changes to the Manual on Uniform Traffic Control Devices in 2009. And now we've been participating in training to facilitate the implementation of these guidelines and provide more information about how they can be implemented in real life. I'm going to go from telling you about the research project and how we've gotten to we'll talk more about the features and what's required on accessible pedestrian signals now as they're installed. But I first want to talk a little bit about travel by pedestrians who are blind or who have low vision, because I think that helps everybody understand better how these devices will be used and helps understanding the features when we start talking about the features in a later part of this presentation. Next slide, James. Basically, first of all, the prevalence of blindness and vision loss is something that's a little bit in question. We don't have any kind of registry of individuals who are blind or visually impaired in the U.S., so it's a little bit taken from census data, from other medical records, but the general definition of blindness as well can vary. So different ways of recording it mean that we have some pretty fuzzy numbers about the number of people who are blind or visually impaired in the U.S. From the census records, we have that some degree of vision impairment affects over 10 million Americans. These are pretty old numbers at this point. We know 1.3 million are legally blind, and we know the incidence of vision loss increases with age. Next slide. The census definition of visual impairment is a functional limitation in seeing, and that's with the best possible correction. So wearing the best glasses somebody can get, they're still having difficulty with some aspects of seeing, reading, being able to see features around them. Legal blindness is actually defined by law and determines eligibility for services. And that is defined as vision of 2200 or less in the better eye with best possible correction. Vision of 2200, just a simplified explanation, is somebody who has vision, what's considered normal vision is 20/20. Somebody who's legally blind basically sees at 20 feet what somebody with normal vision sees at 200 feet. So much reduced visual acuity. Second part of the definition of legal blindness is related to visual field. So a visual field of 20 degrees or less, sometimes referred to as tunnel vision, is also defined as legally blind. Next slide. When you look at the street crossing on this next slide, those of you with normal vision can maybe see a lot of features that you might use or be able to use in making that street crossing. Starting first with maybe the pedestrian signal, the vehicular signal. Look at it for a minute and think about other things that you might be using as you start to make that crossing in order to make your decisions about the crossing. I would assume if you're a careful pedestrian, you don't just rely on the signal. You also would want to be looking at the traffic. You might also be looking at the crosswalk lines to where you're being directed to go, where the curb is, the edge of the street or the curb ramp, other signs that are there at the intersection. You might use the street signs to determine where you are. You might use the edge of the sidewalk or the building line as well, or at least you're using those as somewhat reference points for your direction of travel, in addition to the traffic, the signals, and other information. The next slide, the next picture shows this street crossing as it might be seen with someone with an overall reduced visual acuity. And you'll notice that many of the features that you were looking at a minute ago are not so clear anymore. Just think about some of the things that you can't see here that may be very important to making that crossing. And what can you see here? A couple of features that still stand out that may be helpful to you. Some of the things that are still visible are crosswalk lines, cars if they contrast well with their background, maybe the edge of the street and the sidewalk if there's different color or visual contrast there, signs possibly if there's visual contrast, but can't really read the words on them anymore. You can't, though, see the pedestrian signal or the vehicle signals in this particular instance. So knowing when the signal is in your favor is definitely more difficult in terms of using vision in this particular reduced acuity. Next slide. As this same intersection is seen by someone with what's called a central vision loss, they've got kind of a reduced visual ability in the center of their vision. So again, can't see that pedestrian signal, can't see what's basically straight in front of them, may be able to see things around them, still see crosswalk lines, the difference between the color of the street and the sidewalk, but missing some of the signal information, the details of print. One of the things that I particularly want to point out about this is in my experience in teaching individuals who are blind or visually impaired travel skills, and that's my background, many people with vision like this did not use a cane or a dog guide or any other device that would indicate to you that they are visually impaired and blind. I often talk to individuals who are traffic engineers who say, well, we don't have any blind people in our area, so I don't know why we would need to do this. But the fact of the matter is, many people who are visually impaired and blind are not necessarily using some type of device that identifies them to you as visually impaired and blind. Most people with this type of loss, as I said, would be traveling without using some kind of device. And again, might be able to see the edge of the street, some of the cars if they contrast well, but not be able to see the pedestrian signals. Next slide. Next slide is a kind of the opposite condition of the one you just saw. This is someone who has peripheral vision loss, so the vision around the central part of the eye is obliterated in some way. This means that they may have very clear central vision. Your central vision is the best part of your vision. The peripheral vision is never quite as clear. So that this person can, when they're looking straight at it, can maybe see that pedestrian signal across the street. But if looking at that pedestrian signal, what are they missing? Think about it a second. aren't seeing the edge of the street right under their feet, the car that's right over to their left about to turn the corner in front of them, other features right around them. If they're focusing on the pedestrian signal, they can't focus on what they might be about to step into. Most people with vision this bad are using some type of mobility device, such as a white cane, a dog guide, or other indications they're blind or visually impaired. Next slide. Next slide. Basically, as seen by someone with total blindness, they would have none of the features that we've just been talking about that would might help them in making their decisions about crossing. However, there are other techniques and cues that they might use or will use in making street crossings. People who are totally blind do travel every day and cross streets with some regularity. Talk now a little bit about how people who are blind or visually who have low vision do travel. Next slide, James. They may be using what's called a sighted or human guide, a white cane, a dog guide, telescope or other low vision aids, or no aid at all, as I mentioned earlier. Sighted or human guide may be used by anybody who's visually impaired or blind at some times, but is not usually their main mobility aid. Somebody may travel along with somebody else when they're maybe going through a crowded restaurant or just walking together to go to some destination, but most people do not have a dedicated guide all the time to help them go where they need to go. Many people who are blind or visually impaired do use a white cane, as shown in the photo on the right there, that they move in front of them as they're traveling, detects obstacles, detects drop-offs, and otherwise provides information as well as identification about their vision. Only about 5% of individuals who are blind or visually impaired use a dog guide to assist in traveling. Many people think, oh, well, if they're blind, everybody will, they get a dog guide and that'll solve all their problems. Just let me mention quickly that dog guides don't decide when to cross the street. They follow the commands of their handler. They also don't decide where they're going. The person needs to give them commands that are such as forward, right, left, other directions. The dog doesn't follow a they may know a route they go on a regular basis every day, but they don't necessarily make the decisions about where to go. The person has to give them directions and keep them in line, basically. Somebody who's blind or visually impaired may also use some kind of telescope or other low vision aid. And as I mentioned earlier, some people who are blind or visually impaired don't use any kind of aid at all that would identify them as blind. Next slide. Orientation mobility instruction is provided by orientation mobility specialists. That's my background. I'm an orientation mobility specialist. Basically, our job as orientation mobility specialists are to prepare a person who's recently lost their vision to travel in a variety of environments. We want to teach them to be able to independently assess new intersections and plan new routes, because basically there's not an opportunity for an orientation mobility specialist to work with somebody on every intersection they may need to cross or every place they want to go. Just like most of those of you in the audience who aren't blind, people who are blind or visually impaired every day may have a new destination to travel to. They may have a doctor's appointment across town. They may have a work-related meeting they need to go to at a different building. And they, like the rest of us, may get directions and travel to that new destination. They don't have somebody show them how to get to every new destination they may need to travel to. So I think the assumption by many is that, oh, well, anybody who's blind is going to have somebody show them how to get there. That's not correct. People who are blind get directions just like you do and travel to new locations on a regular basis. And they might travel across town. I've had many times had a traffic engineer say to me, just tell me where the blind people live and I'll fix the area. But people do travel all the way across town, in all areas of town, and their routes may change from day to day depending on whether the kids have swimming lessons that they need to take them to, or whether they have to go by a different doctor's office or go to a different appointment for their job. So it is not something that you can assume that you know where all people who are blind are going to be traveling to. In making street crossings, next slide, there are a number of tasks that need to be completed in order to make those crossings well for somebody without vision. First of all, somebody who's blind needs to locate the edge of the street and the crosswalk. They need to figure out the geometry of the intersection, kind of figure out their proper crossing alignment. That's usually done by listening to the traffic. They also need to determine the traffic control. Is there a signal there, or is it stop control? Is there what the appropriate time is to cross? And then they have to maintain their alignment while crossing, so they're walking across the street in the, hopefully in the proper location and proper alignment in relationship to cars. Most of that can be done quite well by listening, but it's gotten more and more difficult as the signalization schemes have gotten more complex and more difficult and confusing. So it can be a challenge, but it is one that, in my experience, many people do take on and do on a regular basis. I worked for many years in a rehab center working with adults who lost their vision as adults, and basically people wanted to keep on traveling and keep on going places on their own independently, and they did. So just as a summary, next slide, people who are blind or visually impaired do cross streets every day. That street crossing task has become more difficult as geometry and signalizations changed. Being familiar with the intersection, access to more information about the intersection can really make the task easier and safer. Just so that's a little background on travel by people who are blind or visually impaired. I want to talk very briefly about ADA regulations, MUTCD standards and guidance for push-button integrated APS. Next slide, James. And some of the standards that we particularly need to look for, you need to look at in relation to installation of accessible pedestrian signals would be the MUTCD, the Manual and Uniform Traffic Control Devices, and the Access Board, or Proposed Accessibility Guidelines for Pedestrian Facilities in the Public Right-of-Way, sometimes referred to as Draft PROAG or Public Rights-of-Way Guidelines. Next slide. Just to kind of review the ADA issues, the Americans with Disability Act requires that all newly built or altered facilities or programs are, the terminology used is accessible to and usable by individuals with disabilities. Even though there's not actually finalized public rights-of-way guidelines, it's still a requirement in the implementing regulations of the ADA that any newly built or altered facilities are accessible to and usable by individuals with disabilities. That can, even though there are no finalized standards available, engineers are expected to use their engineering judgment in installing stuff based on what's available and the information available. Next slide. The proposed public rights-of-way guidelines were released July 26, 2011. They're very focused on new construction, and they can provide direction regarding ADA requirements for public rights-of-ways. We certainly, as in this project, have recommended that you understand and use requirements in the proposed PROAG as your goal in any APS installation. And basically in proposed PROAG, they require accessible pedestrian signals and push buttons wherever pedestrian signals are installed. Next slide. Then goes on to say that the APS need to comply with sections 4E08 through 4E13 of the MUTCD, and this is the 2009 MUTCD. Also has a requirement in proposed PROAG that all operable parts comply with the regulations that are in a different section of that those guidelines. So there is a lot of information out there about what the the functioning of the accessible pedestrian signals. And as I said, this is not a final rule yet requiring them to be installed wherever signals are installed, but certainly is a recommended practice, I guess. Next slide. It refers to the MUTCD 2009, which was published in by Federal Highway Administration. And I'm going to talk a little bit about the slides that are about the changes that are in the 2009 MUTCD related to how APS should function, because there are a number of standards that changed in this 2009 edition. Next slide. Generally, the main thing to first recognize is that the type specified in the 2009 MUTCD is what's referred to as push-button integrated APS. There have been other types of APS installed, but don't provide the benefits of the push-button integrated devices. They're head mounted ones that many people are familiar with, the cuckoo and chirp from overhead. Basically, we were found in research, both what we did in our project and in other research, to not really provide as much benefit for individuals who are blind and visually impaired, because it was, first of all, you have to find a push button, and it was hard to find sometimes, and they didn't provide a sound throughout the entire pedestrian phase, just during the walk interval. So there were also installed some vibrotactile only and some receiver-based devices, both of which are not currently allowed in the U.S. basically under the 2009 MUTCD. Next slide. What's required in the MUTCD as standards are the various features listed here on this slide, and I'll talk a little more about each of those, but let me just quickly run through. There's required a push button locator tone, so this is the sound that comes from the push button, a tactile arrow, an actuation indicator, required to also have automatic volume adjustment, and the walk indication is supposed to be audible tones and a vibrotactile indication, and can sometimes be an audible speech message. Let me talk a little about each of those features, because they're important to understand, and to understand a little bit about how people who are blind or visually impaired might use those features. Next slide. The push button locator tone is basically a repetitive sound that's coming from the push button. It provides information about the fact that there's a push button there that a blind person needs to push, and also helps somebody find that push button. The push button locator tone is specified by the MUTCD to be 1 tone per second, and that each tone should be less than 0.15 seconds in duration. So a very quick, short tone. Part of the specification is the 1 tone per second, so that it can be recognized. Different sounds are acceptable, and really the main recognizable feature of it is that 1 tone per second aspect of it. There's some that are more what I call beep tones, and some are more click tones. But there are different sounds that are acceptable. The different types of push-button integrated APS do have basically computer chips in them, and they can usually be changed to be different sounds based on what's been loaded up on that chip. Besides a push-button locator tone, there's a requirement for a tactile arrow. Next slide. Tactile arrow on the push button. And that tactile arrow is raised so that a person who's blind or visually impaired can feel the arrow, feel the direction it's pointing, and that arrow is also supposed to be aligned with the direction of travel on the crosswalk that's controlled by that push button. So it's providing some guidance to the person about the crosswalk orientation, as well as the push button, which road the push button is for. So it can be used by, has been used by people somewhat to align themselves for a crossing. So aligning that well on the pole in relationship to the crosswalk is an important part of installation. It can be possibly on the actual push button itself, sometimes on the device somewhat above the push button. picture on the screen shows one manufacturer's device. There are a number of different devices in the U.S. used that have similar push-button orientation and arrow on it. Next slide. It's also a requirement in the MUTCD for an actuation indicator, basically indicating to pedestrians that the button has been pressed. This is both a light that might light up for sighted pedestrians to let them know that the button has been pressed, similar to a light for an elevator. The MUTCD also specifies an audible wait for blind or low vision pedestrians, so that when the button is pressed, there's it basically says wait at that moment it's pressed to let the person who's blind or low vision know that the button has gotten their call, basically. Next feature, next slide, is automatic volume adjustment. And this is one that's a big change from what was previously installed in the U.S. and has made a difference in the kind of the acceptance of accessible pedestrian signals in many ways. These signals respond to the sounds around them. So they get louder when the traffic is louder, quieter when the traffic is quieter. They do need to be adjusted well, and that's part of the settings that need to be done by installers. But they're just supposed to be heard 6 to 12 feet from the push-button or APS device. They're not intended to be heard all the way across the street or all the way down the block. The idea is to provide a signal at the beginning of the walk indication, and then pedestrians who are blind or visually impaired generally want to hear the traffic that's going around them. They want to hear if there's cars turning in front of them, if there's where the other traffic is moving, to provide some alignment cues. They don't want the signal to be so loud that it masks all the sounds of traffic and other things going on around them. So it specifies a quieter signal than many people are used to. There is a possibility of what's called audible beaconing that might provide some information about the direction of the other end of the street, some specifications in the MUTCD for how to provide audible beaconing, but that's actually supposed to be only used if selected. Usually that's selected by holding a push button in for more than a second to call up additional features. And of course would only be if that's been installed on the device in the first place. But it is a standard feature possibility on many of the devices sold in the U.S. now. So that's a possibility that can be provided. Next slide. I think I already mentioned some of this. The sound is responding to the sound at the intersection. The APS is basically monitoring the volume on a second-by-second basis and responding. The volume is not supposed to be more than 2 to 5 dB above the ambient sound. But as I mentioned, you may need adjustment when they're installed because they may be preset for a certain volume range, and if you put them in a location that's louder or quieter or next to a building or other things, you may need to have that volume adjusted because depending on where the speaker's aiming and what's behind it. So that's automatic volume adjustment does make a difference in the sound levels, but it definitely needs some adjustment when they're installed. Next slide. Vibrotactile walk indication. Basically, there's different. This is a walk indication that is provided through that arrow or some other surface on the push button unit that vibrates during the walk. So that not just an audible indication, but also the vibrotactile indication. This communicates information to pedestrians who are blind, as well as ones who can't hear well. Also, there are many people who may stand by the button and use that just to confirm they're hearing the right audible indication. But that only works well if it is close to the crosswalk and close to the street, because people definitely want to be ready to make their crossing when the walk begins and not waste a lot of time with that. Next slide. When we get to talking about the audible walk indication, there are different requirements in the MUTCD for a tone message in some cases and a speech message in other situations. And this basically depends on the location of the APS push buttons. If push buttons are separated by more than 10 feet from each other, the location of the push buttons can clarify which crosswalk is being signaled. And in that case, basically a tone, a rapid tick walk indication, is what is recommended. That was found in our research to be most detectable in traffic noise, to result in faster response from individuals who are blind or visually impaired, and to work better in getting correct responses to the right signal. Where it's impossible in retrofit situations to separate the push buttons by more than 10 feet. It's a person who's blind or visually impaired, or any pedestrian really, can't distinguish which one's sounding by the direction the sound's coming from, the location of it. So in that case, additional features, especially programmed speech messages and other features, are needed on the device. So the MUTCD has these two different situations depending on the locations of the devices. Next slide. On this slide we have some sounds attached to this, but we're not going to be able to play. But basically what you hear when you have the walk indication as a rapid tick is you hear the locator tone during the flashing and steady don't walk. That's constantly going once per second, just a short beep. And the walk indication during walk is a rapid ticking, 8 to 10 ticks per second. So and quickly during that walk indication to indicate the walk. Next slide. The other walk indication, if you need to use speech messages, there's a push button locator tone. Again, the locator tone is constantly sounding during the flashing and steady don't walk, and the walk indication during walk is a speech message, and there's specific wording for the speech messages that is required in the MUTCD. I'll talk about it in just a minute. But the MUTCD also requires, although it is required otherwise, a tactile arrow on anything using a speech message, as well as what's called a push button information message. A push button information message basically gives people the information about what street name they should be listening for, because remember I talked earlier about a person who's blind or visually impaired might be traveling to a new location. How many times when you give directions do you tell everybody the name of the 3 streets they have to cross before they turn right, or something like that? If you're given directions, you basically say go up 3 streets and turn right. So they may need to know which street name they need to be listening for as their indication of a crossing. That if they don't know that the street they're about to cross is Peachtree instead of 4th, they may cross at the wrong time. Next slide. I want to talk a second about speech messages, because often they seem really user-friendly. People think, oh yeah, that's great, I hear the name of the street, I know what's going on. But what we found in the research and in feedback in many ways is that they seem really user-friendly, but it's often hard to understand the words on the street in traffic noise. It's an awful lot of potential for misunderstanding and various sound conditions. Users have to know the names of the street in the first place, and we did get slower response from users than we got for the rapid tick walk indication. Next slide. If you're using speech messages or at locations where speech messages are used, there is a recommended, required basically, walk message in the MUTCD, and it is using the street name first, walk sign is on to cross, and the street name again. So the recommended walk message would be something like Howard, walk sign is on to cross Howard. At locations with exclusive head phases or scramble crossings, you could use a speech message like walk sign is on for all crossings or rapid tick walk indication. But again, the consistent wording is an important part of it. One of the things we found was it was very important to have the street name be the first thing people hear, and then repeated. It's a long message because we found that there was some confusion among traffic engineers and blind pedestrians about which street was indicated if you had a sign that said Howard walk sign or walk sign Howard. People who were blind thought that was to cross Howard, and traffic engineers thought it was for traveling along Howard, so or whatever street name. But it's a long message for a reason, because we had some confusion in the research related to what it meant. So it's Howard, walk sign is on to cross Howard, repeated for the duration of the walk indication. Next slide. I think I talked a little already about the push button information message. It's basically providing the name of the street that's controlled by the push button, and that's the street name that's also used in that speech walk message. And again, the tactile arrow distinguishes the crossing being signaled. So just to kind of summarize the features, next slide. There's a push button locator tone that's once per second. No specific type of sound recommended. You can use different sounds there. A tactile arrow needs to be raised and on the push button. Automatic volume adjustment, so that it changes in response to sound around it. An actuation indicator that's both audible and visual. Next slide. The summary of the walk indication. First of all, it needs to be quiet, not broadcast across the intersection. It's supposed to be audible at the crosswalk departure point. There's supposed to be a vibrotactile indication in addition to the audible. And at locations where APS on the corner can be separated, you want to use the rapid tick walk indication. Where two APS are located on the same pole or closer than 10 feet to each other, you need to use a speech message along with the tactile arrow and the push button information message. That's just a quick summary of the features that are basically required if you're installing APS in the MUTCD at this point. And I'm going to turn it over to Daniel for more about the installation and design guidance.
James, if you want to transfer control of my screen, it should be good to go to take that now. Pardon me while I scroll to my section. All right. What Janet's just covered is a lot about the features of the APS devices themselves, the audible features, things like tactile arrow and vibrotactile indications. And a lot of times agencies, especially those who are somewhat new to installing APS, these are sort of the things they focus on. Rightly so, they are important, but one thing that gets ignored a lot of times is the location of the APS device. And so I want to talk through some of the points related to where you're placing these. In fact, the location of an APS is critical, and this is, I guess, sort of maybe counterintuitive, or at least a change in view from the standard non-accessible type of push button with an assumption of just sighted pedestrians, where the position of the push button is a little bit less important, because if I have full sight, I can see it's over there. I'll go push it. I'll come back to wait over here, and I can just look and see when the pedestrian signal changes. When we're dealing with APS, the location is much more important.
Daniel, sorry, we're having issues again. We're not getting your full screen, so.
Oh, okay.
I'll
well,
take it
why
back
don't you go ahead and take it back? Yep.
Make sure it keeps working. Not sure what's going on today. This is where we need to be, correct?
That is correct. So the newer types, and what I mean by that is what Janet talked about with the push-button integrated devices, where the sounds are coming from the unit, the arrow and the vibrotactile and everything there is with the push-button unit. And in these kinds of devices, the location is critical because it provides information through its proximity and its position. In fact, when you have the APS located correctly, it's going to give a less of a cognitive load to the pedestrian who's visually impaired and making use of the device. I'll show you an image in a minute to show you where these buttons are, but essentially if someone is there on the corner, is visually impaired, and knows that they push the button on the right, and then they hear a walk indication coming from their right, they can intuitively know that that sound is for the crosswalk that they intend to cross. The other part of the location issue here is that if you have the button near the crosswalk, near the departure point, the signal of the APS can be quieter. and that benefits everyone. Next slide. Specifically to the MUTCD, the 2009 version that Janet talked about, there are now specifications for locations of all pedestrian detectors or push buttons, not just APS, and that's in section 4E08 if you're interested in looking at some of the phrasing and guidance there. And then also in 4E10 it talks about for APS detectors that they should be as close as possible to the curb ramp, so where presumably someone would be waiting to cross, and as close as possible to the crosswalk line furthest from the center of the intersection. Next slide. Here are some of those dimensions laid out in the MUTCD about where the APS should be located. It does specify that it needs to be within 5 feet of the extended crosswalk line, and so there we have an example of where that would be laterally from the crosswalk. Next slide. Back one. And it also says it needs to be between 1.5 feet and 6 feet from the face of the curb. So essentially not too far back and not too far out of line. We want to keep the APS close to where someone will be using it and departing on their crossing. Next slide. This is a schematic provided in the MUTCD about the area on the corner where the APS could go to fit these dimensions that are laid out there. It is certainly the case in our one-day workshop. We are fairly quick to point out that this is not a to-scale drawing, and those of you who do curb ramp and corner and such design will probably pick up on that pretty quick. But it gives you an idea of the general area that's being talked about with the 5-foot dimension outside the crosswalk line, not more than 6 feet back from the curb, kind of showing the general area where the push button could be placed. Next slide. Also in the MUTCD, talking about how the devices should be installed. The face of the device, and I think Janet mentioned this, should be parallel to the crosswalk to be used. This allows that tactile arrow that Janet mentioned to be used by someone who has visual impairments to get alignment information as they line up to start their crossing. Next slide. In the other guidance document that Janet talked about from the U.S. Access Board, what we refer to as the proposed PROAG in section R4R6, also has some standards and guidance related to reach ranges where the button should be placed on the pole. And so there's dimensions there height-wise and also protrusion of basically any kind of pedestal base, that sort of, or curb or whatnot from the button, so to allow someone who is using a wheelchair to be able to access the button. Next slide. And this is an example image of APS that is definitely not within the reach range. Someone who's in a wheelchair would not be able to reach that far to the push button. Next slide. Here we have an example of one that would be usable by someone who would be in a wheelchair or not, placed very close to the departure point. This one here is not the fully accessible pedestrian button, but it shows position-wise where that would be able to be placed. And in fact, if you do have that kind of infrastructure, a pole, short pole there, you might very well be able to use that to mount the APS on. Next slide. Also, the MUTCD talks about when you have 2 push buttons on a corner, you need to, if at all possible, separate them by 10 feet or more. And this is an image showing 2 APS that do have that kind of separation, a good amount of separation, in fact. In this picture, you can see they're also placed close to the curb and close to that crosswalk line furthest from the center of the intersection. Next slide. Another picture showing 2 APS on the corner, smaller radius corner here in this picture, but they did achieve a 10-foot separation. Next slide. So you might have, and probably will encounter if you're doing this somewhat widely in your city, you might have this situation where you can't get the APS separated by 10 feet or more, as the MUTCD says is the ideal case. Maybe you're doing a retrofit where you're just installing APS on the existing infrastructure. So let's talk a little bit about that. Next slide. And we'll talk about it from the MUTCD language. If you're not familiar with this, I'll just let you know what it says. It says if you can't get that kind of separation, 10 feet or more, then you shall use an APS with the following features, and here we have a list: the locator tone, tactile arrow. These are things on all push buttons on all APS. But C there says a speech walk message, and so if you recall, Janet talked about the two types of walk messages, a speech or a rapid tick, and this is the case then where you would use that speech walk message. Along with that, you also have to have, it says D there, a speech push button information message. As Janet mentioned, that someone might not be familiar with the intersection, and in order to be able to use the information that's provided from the speech walk indication when it says Howard walk sign is on across Howard, they need to know which street is Howard, and so that also needs to be part of what's provided if you cannot get that kind of separation at the corner. Next slide. So an example photo here showing two APS on this one pole here. So again, a situation where for whatever reason separation wasn't possible. Looks like this is probably on an island. There may be some issues with that. And so the two push buttons would have speech walk messages, and those are given there as examples. First of all, the wait message, if it's during the don't walk or the flashing don't walk, wait to cross Grand at Howard. And then for the speech walk indication, it'd be Grand walk sign is on to cross Grand. So always starting with the name of the street to be crossed, and then saying walk sign is on to cross. And so this is the prescribed language then for the speech walk indication. Next slide. So to summarize, what is your ideal installation? If you can get the ideal installation, here's what you want. You definitely want it to be adjacent to a level landing. For those in wheelchairs accessing the device, the face of the APS should be parallel to the crosswalk, so take care how it's mounted on the pole. Location-wise, it shouldn't be any more than 6 feet back from the curb or 5 feet out of line with the crosswalk, ideally between the curb ramp and the crosswalk line. And then if you have two APS on the same corner, no less than 10 feet between them. So these are kind of your key metrics to keep in mind when you're designing how a corner should be laid out. Next slide. And this is an image showing that that ideal installation here. So we have two APS shown as the boxes with the arrows here mounted on poles. We're looking at an overhead view of an intersection corner. And the two ramps are serving crosswalks individually. The devices are separated by 10 feet at least. They're placed on the side of the pole toward the center of the intersection, so take note of that. And so as we see here, this person who's waiting to cross here, if he hears the walk indication coming from his left, he knows that's the one for his crosswalk. The location itself is giving that information. So here we have, again, the reason that location is more important with APS than it is with the standard non-accessible push button. Next slide. What we'd like to do to finish up here is to look through some design exercises, because it always is the case that showing pictures is a good way to get a point across. And so we'll kind of give you some thought exercises, some before and after pictures, and then some other ones to kind of think about. And if there's more than just yourself there in your office or conference room, feel free to discuss it with whoever's there. So we'll go into this, and I'll kind of lead, and Janet's going to chime in with anything that I miss or forget. So why don't you go ahead and give us the next slide. So some of these first ones are from agencies that we've worked with as part of this research study. Here we have an intersection. We're looking at it across the street of the intersection, and this is the before condition, and so we have only one push button here on the left side for the crossing that's straight ahead of us. It's non-APS. And the situation I pose to you is that you are tasked with retrofitting this intersection with APS for both crossings, the one straight ahead of us and the one to our left. So take a moment to think, where would you put the buttons, and how would they be configured? You've probably noticed the wooden utility pole there on the right side of the screen. It depends on what kind of rules your agency is under. Some places they're not allowed to touch the utility poles. In fact, in this location they were able to use that pole for push-button needs. And so why don't we go ahead and go on to the next slide, and we'll show you what the agency did when they installed APS here. So they used the wooden utility pole there for the push button for the crossing straight ahead of us, which puts it on the correct side, which is the outside away from the intersection side. It is parallel. It's well placed parallel to the crosswalk. For the crossing to the left, they used the existing metal pole that was there and just took the button and removed the one that was there and put one on the side facing the intersection and APS there. So this is a place where they were able to use the existing infrastructure to put buttons in good placement for the crossing, and these were able to be separated by 10 feet, and so they used the rapid tick indication here. They did not need to go to the speech walk message. Next slide. We'll look at another intersection actually just down the road, or excuse me, this is the other corner of the same intersection. We've got another one in just a second down the road. So here we're looking at a difference. We're kind of across the street a little bit from where this the first picture was. So again, I present to you a situation where you need to retrofit this this corner with APS, 2 APS, one for each of the crossings that we encounter here. There is a pole on the right, as you see, with the button that's on it for the crossing to our left. That's the main street to our left. So take a second to think about where would you put buttons and how would you do it for this corner. So one of the differences here is we only have one existing pole, that wooden pole on which the PED button and the PED heads are mounted right now. And so maybe some of you have thought, well, okay, on the left side for crossing that major street there, maybe there needs to be an additional pole added. And a lot of times this can be a good solution for places where you have this kind of setup. So if you go on to the next slide, we can take a look at what the agency ended up doing. They have added a pole there. Back one, there you go. And that houses the button then for crossing the major street, and that's been placed near the curb and within the crosswalk extended. The wooden pole to the right is then used for the crossing straight ahead of us. So again, a place where they could get the separation, the 10 foot or more, use the rapid tick, and have buttons that are well placed for the pedestrian to be able to use them. Next slide. On down the road here, we have another location. Looking across the major street here with the minor street to our right. Same situation, we want to put APS here. You can see in the foreground there's a utility pole that has the PED button for crossing the street ahead of us, the major street. You might be talking about where would you add extra poles if you want to go that route, and in fact the agency did go that route, and you're probably noticing things like the rutting on the right-hand side from turning bus traffic. You might be noticing the small stone wall on the left, and that actually was a constraint here because that wall is historic and cannot be touched. So there's a few constraints working here. But we'll go ahead and take a look at the next slide and see what the agency did in this location. And they actually did install poles, actually 2 extra poles, since that wooden pole was too far back from the intersection to be useful. If you saw how far back from the curb it was, probably was a good 15 or 20 feet back. So they've installed 2 new poles here that are well positioned near the curb, and there was some concern on the agency's part about that turning bus traffic, but in fact I think the bus drivers must have changed what they were doing when there was a pole there, and that pole was stood for a number of years. Haven't gone back there in a few years to check and see if it's still up, but it certainly didn't come down in a month like they expected. So we can see the devices mounted again on the side of the pole that's toward the center of the intersection here. Next slide. Wanted to show you an example of a place where 2 push buttons were put on the same pole, and some of the ramifications that can happen when you do go for that kind of installation or that kind of solution. So when we look one way, we're looking across the street here with that pole to our right that has the 2 push buttons on it. We can see that the push button for the crossing ahead of us is probably within 5 feet of that crosswalk. It's not that far back from the curb, so locationally it's pretty well placed, usable for someone. But the effect is that even though it's well placed for that crossing, when we turn to our right and look across the street the other way, next slide, we can look and see what some of the ramifications are for that other button. So here we have a situation where the button is definitely more than 5 feet away from that crosswalk, so it's farther away. It's going to have to be louder if someone's going to wait at the crosswalk. It is, to their credit here, it is pointing toward the destination curb, and so if someone were to follow that alignment of the device, they would be able to reach that actually right at the curb ramp on the other side. But some of the issues here, in addition to it being farther away from the ramp, excuse me, is that if someone's waiting next to the button, as someone who's visually impaired might do, not needing to use the curb ramp necessarily, they might really prefer to step down from the curb itself. If they are waiting there, they are going to be very much visually shadowed from vehicles turning right. So this is certainly a situation you don't want to get into either. So sometimes it's necessary to use the existing infrastructure for whatever reason, and in this case, 2-on-1 poles, so they're using speech messaging here. But it is certainly worth considering the ramifications of going with something like that. An additional pole to the right for that crossing would have really been helpful in this instance. Next slide.
It also helps a person who's blind or visually impaired know where the crosswalk is, where to start from the right place instead of from someplace outside the crosswalk where drivers may not be looking for them.
Yeah, great point. I had the opportunity here where I live in North Carolina to witness some before and after work on a corridor that was near a college campus, and in the midst of that they were doing also revising the pedestrian facilities there, and they were adding APS, and so I was able to take some before and after shots there. So this is going to be a couple intersections on this corridor, and so we're looking at an intersection right here that previously had a button you can't see because it's behind that box that's mounted on the pole there for crossing the major street and nothing else. So this is the before shot, and we can take a look at the next slide to see some of the after shots after they installed. So this is across the major street. They actually did some work on the street itself to do a road diet, a road conversion there, bring the crossing width down some. On the right side of the picture, you can see the metal pole that they've added with the ped head and the APS on it to put it closer to the crosswalks to where someone's going to be waiting. If we take a look at the next slide, we can look to our left across the minor street and see some improvements they made there. They added a pole and an APS and actually a whole pedestrian phase there for that crossing, fairly well situated close to the curb within 5 feet of that crosswalk, facing the intersection, so it's going to work well locationally for the person. They've done other improvements here as well, like adding the high visibility crosswalk markings there. Take a look at the next slide, and we can go to the other side of the street from where we're at right now and look at the other side where they also added a pole with an APS mounted on it for that crossing back. I would have to say on this one, I probably would have recommended that they move the pole closer to the curb and not so up against that wall, because they've really encroached into the free travel space for someone who's in a wheelchair traversing the sidewalk there. So generally speaking, pretty good. Could have used a little bit of change up of where they put that pole up against the face of the curb would have been probably a better suited location, 1.5 feet, as the METCD would call it. Next slide. Down the street some, another intersection here. We see we're looking across the mostly we're looking across the major road, and you can see in the right there about in the center the wooden pole that has the push button on it, a non-accessible push button in the before condition for crossing the major street. This corner particularly has a lot of clutter on it. For someone who might be navigating with a long with a white cane would have some difficulty in figuring out where the push button is here. There's a telephone utility thing right there in front of the push button. There's also guy wires coming down, an emergency pole, and whatnot. So there's a lot of things going on here. If we take a look at the next slide, we can see what they've done in the post condition here after the corridor was revised. They kept the pole location where it was for crossing the major street, put a new pole in there and have an APS mounted on it, and also added an APS on the other side of the corner for that crossing. They were able to separate them by 10 feet, and that is the advantage when you are adding poles as part of a streetscaping project or general pedestrian improvements, is that you can get that kind of separation and not having to work under the restraints of existing infrastructure. And that is something I try to point out to agencies that are doing revisions to corridors, is that getting poles in the right place when you're out there doing work is very important, because if you aren't having APS out there immediately, if you're going to add them in later, getting poles in the right place will save you a lot of trouble and money if you have to go back and move poles later, so certainly you don't want to get into that kind of cost. So consider this, get those poles in the right places when you're out there doing the work, and really set yourself up better in the long run. Next slide. Here's a picture for you to consider and think about some of the things we've talked about here. So we're looking across the street, straight across the crossing there. Curb ramp to our left, pole to our right that has an APS mounted on it. And my question to you is, what do you think? Is this okay? Some of the requirements for having a push button placed at a crossing is that it needs to have a level area at the push button for someone in a wheelchair. If you go to one click on the slide there, James, we can see that it does have this level area that's at the push button, so it is accessible that way. And the other stipulation is that it needs to have an accessible route to the ramp. And one more click there, James, will show us that there is an accessible path to the ramp. In fact, this is okay. This is an installation that works both for those who have visual impairments and for those who are in wheelchairs. It very well may be the case that someone with visual impairments is going to stand at that push button and actually start their crossing right there, stepping off the curb. Going off the curb gives a good indication of where that crossing starts, whereas someone with a wheelchair will just go around and wait there on the ramp. All right, next slide. So here's another one to consider. We're looking across a crossing here, push buttons to the left mounted on the pole, kind of at the top of the flare of the ramp. So the question here is this okay? And for those who can see the picture clearly, I think you'll pretty quickly pick up on the fact that there's a set of poles in the foreground there that's actually preventing that level landing. So as opposed to the one we were looking at previously, this one does not have a level landing that's accessible to the push button. So someone who's in a wheelchair needing to use this push button is going to be having to hold their wheelchair on that flare of the ramp while trying to do that and push the push button at the same time, which is no easy feat. So this one gets an X. This is not acceptable, accessibility-wise. Next slide. One of the things to keep in mind when you're using existing infrastructure, you might have poles that are well located. As we see here in this picture, we're looking across a crossing. There's a pole to our right, and it's right in line with the crosswalk line, apparently near the curb, so it seems to fit those kind of locational stipulations. One thing to keep in mind, though, when you're doing this and using the existing infrastructure, if you look to the top of that pole, you'll see the ped head that's actually for the crossing to the left. For the one perpendicular to the crosswalk ahead of us. So if you're going to be mounting a push button to this pole for the crossing ahead of us, just take care in the wiring, basically. Make sure that it's being wired to the ped head that it's operating with. So in this case, not to the ped head that's right there shown in the picture. I think if you click once, James, it shows the arrows there to distinguish what I'm talking about here. So just again, think through and be sure to communicate to those who are going to be doing the installation, the wiring in the field, and be clear about what needs to be, how things need to be configured. Next slide. We're showing a picture here of a crossing, pole to the right, APS to APS mounted on it. Do you see issues here? I think it's pretty quickly apparent that there certainly are issues. We've got the two buttons on one pole, but the pole itself is nowhere near the intersection. So for the crossing that's straight ahead of us, the pole is certainly outside the 5-foot range of that crosswalk. So someone would need to go over it and push the button and come back to the start of the crossing. The real detriment here is that for the crossing that we can't see to our left, the push button for that crossing is a good 20 or 30 feet back from where essentially where the person would be starting their crossing from the curb ramp. So if we think about the MBTCD language, that the APS sounds need to be audible from the departure point. In order to be audible here, this device is going to have to be really, really loud. And in fact, it was. And when you're in this kind of an area, that sound's really going to bounce around from those surrounding buildings and parking decks and that sort of thing. So just another point to consider, if you're using existing infrastructure like they did here, think about the ramifications, the usability, the fact that the sound is going to have to be louder. And just to repeat that point, Janet touched on it, but louder is not better for anybody. And that's a counterintuitive point sometimes to those who aren't experienced with the issues that surround the travel of those who are blind or visually impaired. They don't want to have booming sounds either from the APS because they want to be able to hear traffic movements. And also those in surrounding businesses and residences don't want to have loud APS sounds either. So work to get the APS close to the departure point so the sound can be kept down low within 6 to 12 feet hearing range as the MUTCD specifies. Next slide. This is a photo showing a crossing. It's actually got a light rail coming through the middle of it. We see a pole to the left that has the push button, the pedestrian push button mounted on it. And this is actually part of a corridor that was had some significant revisions done to it, I think as part of the light rail, if I recall correctly. And so that pole there was actually added fairly recently when we took this picture. And it's actually kind of unfortunate because they were adding APS on some of these crossings, and they had the opportunity when they were doing that to get those poles in good locations and just missed the opportunity to do it. Didn't really think about that, and so even though this has an APS on it, it is farther than 5 feet from the crosswalk line. It's questionably more than 10 feet back from the curb, certainly not close to where someone would need to use it. So just another point, when you're putting in poles, get them in good locations, and you'll be set up for having good APS and accessible crossings. Next slide. So how's this one look to you? Here we're looking across the street. We've got an APS mounted on a pole right in front of us. If you think about distance and location stipulations from MUTCD, it's within the 5 feet laterally from the crosswalk. I would say it looks to be within 10 feet from the face of that curb, so it's positioned well. The face of the APS is going parallel to the crosswalk, so it's been installed well. So someone can get some alignment information from that. So yeah, this one works very well. Can't tell what the sound setup is from this picture, of course, and sometimes we find that the way that agencies have configured sounds or whatnot do cause issues depending on the location. But locationally, where it's placed, this one does work well. Next slide. We see a picture here of an intersection corner that has APS mounted on it, but if you can tell, there's not a level landing nearby, and that certainly is a prime issue here with this crossing, that for someone to be in a wheelchair and accessing these push buttons is going to be very, very difficult. Next slide. I mentioned that sometimes location can work, but the sound settings that the agency goes with cause a problem, and essentially that's what this situation is. This is a city that Janet and I were in teaching, and we noticed that this one intersection corner that we're looking at here, very large intersection, and we're looking at the corner that's got one pole there. It's a master arm pole. It's got both APS mounted to it, which sort of could work, but the way they've got it configured is that the speech walk indication, which is what they're using here, says walk sign is on, and that was it. If you think about a pedestrian waiting at either one of those curb ramps, if they hear walk sign is on and they know both push buttons are there kind of between the ramps, that's really unhelpful to them. They know that one of the crosswalks is on, but there's no way to tell which one it is. So they needed to use the MUTCD message of First Street walk sign is on across First Street, or First walk sign is on across First.
And ideally, they'd locate those push buttons closer to the destination where somebody's going to be crossing from. But
absolutely,
because they're quite a ways back.
You could add small poles to the left and right to house those push buttons and wire them to the signal. Yep. And I know that a lot of times that does cause issues with getting into the concrete, tearing up concrete, whatever is needed to put those poles in. But thinking through the usability of the intention of putting APS at the intersection, you want to get in places where people will be actually able to use it and will use it. And so these are things that you really need to think through and consider. Next slide. Before we close up here, I just wanted to mention a few things about the APS workshop, and you can go on to the next slide here, James. This is the one-day workshop that Janet and I teach and have been teaching for a number of years to walk through in more detail all of the points that we've talked through here, as well as a few other ones. So it's a full-day workshop, and it's taught by Janet and myself in person. This is how we've been doing it for these past several years. Next slide. If you're interested in hosting a workshop, you can get a hold of me. There's my number, 919-962-8720, or shoot me an email at daniel_carter@unc.edu. We can talk through what you might be looking to have there at your facility. Basically, what we ask of the host agency is to provide a room, to do the advertisement for the course, to handle registration. It has been free through the NCHRP project that we're working on through this spring, or excuse me, I need to update that slide. We had an extension, so actually it's spring 2014. We will continue to offer it after that, and you'll just need to talk to me about what the availability is and any cost associated with that. So if you're interested, please let me know, and we can talk more about that. Next slide. And the last resource I wanted to leave you with is our website, which is www.apsguide.org. The large guidance document that we produced out of this research project is available there in a PDF form if you want to look at it or print it off. Also, the one-day workshop that I just mentioned, we have an online version of that, sort of a walkthrough by yourself, looking at each of our slides that we present, as well as the text of what we typically say with that. So all of that is also on this website, and I encourage you to go check that out. If you want to learn any more about some of the different points that we've talked about here, please do take a look at that. Our contact information is also on that website too. And that takes us to the end here.
All right, we've got about 10 minutes left for some Q&A. So already got a bunch of questions, but if you've got additional questions, go ahead and type them in now, and we'll see if we can get to them. The first question I have is, if retrofitting an existing intersection with push-button integrated APS, is there a requirement to then make the intersection ADA compliant, including existing curb ramps? And also, how do you prioritize, given limited funds, whether to go with the APS or the curb ramps first?
You're taking that one, Janet.
Well, the first is if you're retrofitting an intersection in response to a request by an individual who's blind or visually impaired, basically there is, my understanding is if you're doing a signal project, there's not a requirement that you bring all the curb ramps up to standards at that time. Certainly should be on your list to do when you do some renovation or other work there. But if you don't tear up the curb ramps, you're not required to replace them when you're doing an installation of an accessible pedestrian signal. If you tear it up, certainly you need to put it back right, not like you had it if it was wrong. But there is not a requirement to extend beyond the scope of the request that you have. For many people who are blind or visually impaired, they don't really care what the curb ramp is like. They're more concerned with getting the signal information and can step off a curb. There may be exceptions to that, and you certainly need to be asking the person who has made a request what they need. But I would say if you've got a request for an accessible signal only on one crossing of an intersection, you could do that without doing the entire intersection, without doing any of the curb ramps, if that is what your request is for. What was the second part of that question? I think there was something else there. How to prioritize. There is a, if you're doing a lot of intersections, have a lot of requests, we did, as part of this project, develop a prioritization tool to use in prioritizing installation of APS based on the features of the intersection, characteristics of the intersection. I encourage you to look through the document and the website that Daniel mentioned just to find the information on that, or contact us.
Okay. My next question, I've gotten several versions of this question. What do you do when you're trying to put a push button within 6 feet of a curb for the visually impaired person, but you also have to deal with an 8-foot-long ramp for someone in a wheelchair due to a 6-inch curb. How do you accommodate both?
If you recall, there was one image in those design examples which kind of approached the situation. It was the one we talked about, had the level landing and the accessible path to the ramp, and so that was an instance where, and they had the room to do it, but they put the push button pretty close to the curb and beyond the flare of the ramp, so that this might be possibly a solution to your situation, where you can put the push button somewhere that someone can access it, and a blind or visually impaired person could use it where it's at, and someone in a wheelchair could go around. Certainly there's a lot of different situations you might run into in terms of how wide your sidewalk is and that sort of thing, but that it doesn't necessarily always has to be at the top of the curb. There are other places where it can be. Janet, you want to add anything to that?
Well, just also add that the MUTCD has an exception that allows it to be 10 feet from the curb, because that question was asked in the discussions, I believe, or in the response to the when the NPA was published on the MUTCD. But it is basically as an exception, so it's the goal was to get it closer to the curb if at all possible. Also depends on your curb ramp design, and you might want to look at the curb ramp examples that are in the APS guide for some different designs, because certainly if you've got a sidewalk at back of curb and you need to use a different type of ramp and a different kind of location of installation, so it kind of depends on what you're doing in
well,
terms
in particular, those with narrower sidewalks, one thing I've really wondered why agencies don't use more is a parallel curb ramp design where you bring the entire sidewalk down rather than having the ramp come in at perpendicular to the sidewalk. So something like that could maybe work better with when you have narrower widths for the sidewalks as well.
All right, great. Can APS be installed partially at an intersection, for instance, the west and south legs, but not the north and east, to accommodate where associated ramps are compliant for crossings, but not then for others?
I think it depends on why you're installing and when you're installing. If it's a retrofit in response to request or part of your transition plan, then certainly you can do different things in those kind of situations than you would do if you're already working at that intersection and renovating the entire or reconstructing the entire intersection. In retrofit situations or alteration situations, as they're referred to in the ADA, you can make some adjustments. The goal is to install them at all locations where you have pedestrian signals. That's the assumption, or I believe that's the goal of the Access Board in their draft or proposed regulations. But certainly in a retrofit situation, you can do other things, and I would encourage anybody making those decisions to document carefully, to be sure that they are considering all the issues there. And remember what we just said about whether the ramps are compliant per se or not is not always an issue for a person who's blind or visually impaired. It may be that there's one crossing they want to use that goes between the store and the bus stop, and the ramps aren't compliant, and the ramps are compliant on the other two crossings, but they don't take them where they need to go. So I think if you're responding to a person who's blind, that request should be looking at what the needs are and what crossings are needed for that person. Not just at where the ramps are compliant, because it may not get them where they need to go.
All right. Does the lateral reach range accommodate children in wheelchairs?
I believe that lateral reach range is intended to accommodate children in wheelchairs, but that is not really my area of expertise. Certainly something you should know about and consider using in your answering questions such as this is the Access Board does have a technical assistance phone line that you can call. If you look up the Access Board's website, it's access-board.gov. You can find that number or their email address to request technical assistance, to ask a question such as that. But I believe that's part of why it's been brought down to 10 inches and 48 inches as the highest. Is partly to allow for people with smaller stature.
Okay, great. Got a lot of questions now, very similar to this one. Can you describe how to use an APS with a mid-block crosswalks that have pedestrian-activated flashing beacon systems, such as an RRFB?
Yeah. There's not any specific guidelines related to that at this moment because there isn't a pedestrian signal. It's not actually an accessible pedestrian signal you'd be installing there. But certainly what I'm hearing from individuals who are blind or visually impaired is that they want to have access to those devices just as somebody sighted has access to them. There are devices available from various manufacturers that have a locator tone, so a person who's blind could find the push button because if they're push button activated, a blind person needs to first know they're there and know where the push button is. Those devices, at least what I've been recommending, and I think this is now what the MUTCD team is recommending, is the devices provide a speech message that says something like the yellow lights are flashing during the time that the RFBs or whatever they are activated, and that they are just provide that there's not a vibrotactile indication on that type of device because that might indicate to somebody they have a walk indication or a more clear, maybe confuse them about it. Also, one of the things I want to say is it needs to say the yellow lights are flashing, because I was working with some people who are blind in a location where a RFB was installed with a message that said something like "cross with caution, cars may not stop," and they assumed that the cars had a red light and they were just getting warned that they should cross carefully. So I think it's really important that those messages say it's just yellow lights, because that wasn't clear to a person who's blind.
Okay. I think we have time for one or two more questions. Let's see. How do you sign or mark a no crossing at a crosswalk?
Yeah, so go ahead, Jen.
Well, the access board in the proposed regs has a little advisory note in there basically saying where no pedestrian crossing is allowed, you need to have some kind of detectable edge or fence preventing somebody from thinking that's a location to cross. That if you're preventing, it is not, if I remember correctly, it's not a standard, but it's an advisory note stating that if you're closing a crossing, you need to really close it to individuals who are blind, not just put up a sign.
Yeah, basically, if there's a reason you think that someone crossing on foot at that particular leg is going to be an issue or safety concern, simply putting up a no pedestrian crossing sign, or in one agency I know about that said that they simply didn't paint a crosswalk. That was their way of implying that someone should not cross there. This is not going to work for someone who has visual impairments. You really need to, if you think there's a problem there, put up something that, like Janet said, is a physically blocking sort of a hard indication that there is no crossing to be had here.
All right, well, thank you. Unfortunately, that's all the time we have today for question and answers. I'm sorry if we didn't get to your question today. A PDF copy of the presentation slides will be available later this week at pedbikeinfo.org/webinars, and a recording of today's program will be posted to that site as well as to our YouTube channel, which is youtube.com/pedbikeinfo within a couple of weeks. Be sure to follow us on Facebook. Again, that's facebook.com/pedbike for updates. I want to remind you that a very brief survey will appear once the webinar has ended. We'd very much appreciate you taking a moment to complete it. I mentioned earlier that this webinar has been submitted for AICP credits, and I got several questions about AER credits. We do not have contacts with them, but you will receive a certificate of attendance, and you can submit it to them, and maybe they will give you credits there. Finally, I want to thank all of you for attending, and I want to thank our speakers, Daniel Carter and Janet Barlow, and I hope you all have a very good day.